Welcome everyone. Today we have our another new episode and we will discuss on the hydropower. We have our world famous speaker Mr. David Smith and Mr. Rob. First I would like to give chance Mr. David Smith.
Well, Sharif, thank you. Hydropower is a very interesting one because if we look back through our civilizations, humans have been using and harnessing the power of rivers uh, and ocean waters for centuries, using things like water wheels spun by the rivers to produce grain, to do fabrics, to do all different types of things. So, for example, today in the United today, hydropower provides about 16–17% of the world's electric generating capability. And for example, in the United States, hydropower is used in all except two of the states. And it really goes back a while to see how it has been used, for example, for an electrical source. And that really started in the late 19th century. Uh, and when the first modern water turbine was developed. And so in the United States, the first hydroelectric power plant began operating in 1882. So you see that there's some very interesting history with it. And what's also important about hydropower or hydroelectric power, depending on the terms you want to use and the different nuances around it, it is a renewable source of energy that generates power by using the force of water, by using a dam or a diversionary structure to alter the natural flow of a river or other body of water like a lake. For example, around me here in Austin, we have multiple dams on the Colorado River, which are all generating hydropower. And so hydropower really relies on the constantly recharging system of the water cycle to produce it. And it's using a that is fuel, so water is not eliminated in the process. So it's very kind of sustainable as long as you're not in a drought situation. And there are many different approaches to it, many different kinds, though most of it boils down to the simple fact that all of them are powered by the kinetic energy, and the kinetic energy of water flowing as it moves downstream from the rivers, the streams, and the lakes, uh, and is using that kinetic industry. And the hydropower uses turbines, wheels, generators to convert that kinetic energy into electricity, which is then fed into the distribution system. And because it uses water to generate electricity, those plants need to be located on or near a water source. And the energy available from this really depends on both the volume of the water flow, so how much water is flowing, and to the what's the velocity of it. And the velocity of it is usually accomplished by a change in I can't even talk today. Changes in how much pressure is being applied from one point to another. The greater the flow, the more electricity can be generated. And it goes and spins the blades that way of all the different types. Um, and it's a great, like I said, sustainable, clean source of energy. You know, it's a free resource in most instances. It's very efficient. About 90% of the captured energy on it will be converted into electric power. So let me just compare that, for example, to wind and solar. For wind, only about 59% of it's converted into electric power. And for solar, only about 15%. So it's very, very, very efficient. Uh, and most power plants do not pollute the water, the land, or the air, unlike most of the other power plants. It's renewable. And it can actually help not only save part of the environment, but it can be something that can contribute to economic development. You can use the dams and other things to help have a better water supply for farming, manufacturing, other activities like that, and a larger habitat for fish and the other animals around it. So there's so many advantages and disadvantages of it. I think this is an okay introduction to get us there. I'd love to see where Rob begins to take it.
Mr. Rob.
So I'll go to the problem and future promise of hydroelectric power. The problem with hydroelectric power right now is because of weather change, our rivers, in a lot of areas, our rivers and lakes are drying up, and you can't have hydroelectric power if you don't have water. And so in a number of places in the United States, including here, there's been a real problem in getting enough water to the generators to generate power. It's not at crisis yet, but it's getting close. And with climate change, you've got issues. And if you get too much water, the dams that you build to house the generators will fail, and that water will be released suddenly. And if you've ever seen pictures of what happens, movies have certainly done us, provide us with some glimpses of what happens when a dam fails upriver from a town. It can wipe the town out. And so you've got those dangers with climate change, that what was a relatively stable power source has become very unstable in a lot of areas of late, both due to a lack of water and due to an excess of water. And recognize that dams are typically built and hydroelectric plants are typically built to last centuries, not even decades. So it's not like you can go in and modify them aggressively once they're built. They just weren't designed that way. So it's not a very flexible power source. Where if you look at wind and solar, you can move the panels relatively easily. If you've got too much sun, well, you're going to cook, but it has nothing to do with the solar array. And if you have too little, very much like what happens with water, you can't generate. But once again, you can move them and relocate them. You can't do that with a dam. So the yield, energy yield from hydroelectric, as Dave pointed out, is far greater than the other two choices. But hydroelectric power's downside is it's not movable, it's not portable. It is very difficult to alter for the changes in climate. Impossible, actually. So from a fiscal standpoint. So that's raised a cloud over hydroelectric power of late. And another issue with hydroelectric power is as water has been depleted, fisheries have taken a fairly big hit. Freshwater fisheries have taken a pretty big hit already, and dams can disrupt the spawning cycle. You can do a number of things to mitigate this, but we just had a dam here that was functioning just fine, removed because it had so disrupted the spawning of salmon that it had almost destroyed the related fisheries. And a lot of the state's income comes from salmon fishing, Washington even greater. So it has some negatives. The aspect of hydroelectric power that has been gaining in traction, however, is surf generators, tidal force generators. So the power of the ocean is increasing. Tidal force generators are largely placed underneath the ocean with some type of a wave capture mechanism on top to capture either the tides movements or the wave movements to generate power. And these have been increasing in interest and capability of late. And clearly the ocean isn't going anyplace. So the chance of losing water and reducing the capability of these generators is non-existent. And in gaining water, since they're mostly submerged anyway, unless you gain so much depth that they collapse, at which point we're probably all dead anyway, they don't have that much risk either. Downside for tidal force generators is they have to be on the coast. You're not putting a tidal force generator on one of the Great Lakes in the U.S. You're putting it off the coast of California, Florida, New York, or one of the other coastal states. So you have transport loss. You can't put a tidal force generator where you need the power, because unlike wind and solar, it has to be on the coast. Now, another way to use hydroelectric power is energy storage. This has been played around with quite aggressively. The idea is to use, at least the ones I'm familiar with, either use a mountain or a mine, a very deep mine. And when you've got power being generated for something like solar or wind, you pump the water up. And then when you don't have power, you let the water go back to its lower state and generate energy that way. And so it's and given once again the efficiency of water, which exceeds often the efficiency of batteries, including lithium-ion batteries, which have proven somewhat problematic at city scale. It is a viable way to store energy. The downside is if you're in a flat area with no mines, then it can be very costly. You have to build towers, basically large water towers, and pump the water to the top. But recognize when that water's on the top of a tower, you get a pendulum effect. If there's any kind of an earthquake or any kind of geographic movement and slippage, and that pendulum effect could collapse the tower. The amount of structural reinforcement that is required for water tower is pretty significant in an earthquake area. So the one downside of the tower approach, on top of the cost of building the tower, is the fact that it may prove to be a risk during a time of earthquake due to the pendulum effect of that mass of water, which would be high during the day and lowering at night. And as Dave pointed out, it's one of the oldest forms of capturing power, but it's also one of the most consistent. It carries viability in both these forms off into the future if we look at both tidal and energy storage. So it's an interesting mechanism. As we look at alternative ways of living, a lot of the folks that live off grid that have streams and rivers near them will use small hydroelectric generators, which are more efficient than wind and solar, to generate power for their homes. But it does bring up one other problem with hydroelectric power, and that's that water and mechanisms don't mix well, particularly water and metals. You get corrosion, and you can mitigate that corrosion somewhat by making sure that you use the same type of metals and you don't have two different types of metals adjoining each other so that they interact under the water. And you can coat the metals so that they don't react with the water and begin to degrade and corrode. But that coating does wear off, and it does increase the need for ongoing maintenance. And if we're again looking at tidal generators, that means somebody needs to go down there. Ideal case for robots. You can certainly build robots to do this work. And as we advance artificial intelligence, allowing those robots to go down and be able to react to the tidal forces and move in those unique areas is going to be an interesting challenge, because the water moves quite rapidly in both directions. If you've ever scuba dived and you go down and experience the tidal forces, you move quite a bit if there's a storm coming in. And can you imagine doing detailed work, trying to repair something while you were being pushed backwards and forwards, maybe 3 or 4 feet or up to 10 feet, depending on the surge, while you're trying to work? The kinds of thrusters you would need and sensors you would need to overcome that do exist, but building that particular solution would be a unique challenge for a mechanical and electronic engineer. Be a fun challenge. I think it'd be a ball to build something like that. But it has a number of unique uses, and as I mentioned, a number of unique problems, and that's my opening.
Thank you, Mr. David Smith. Can you unmute, please?
Sharif, thank you, and Rob, that was really good. What you said there too, particularly about the ocean, because the ocean currents are really important and becoming more and more used all the time as a way to get higher efficiency. The other way, Rob, where I'm seeing it used, and particularly around me here in Texas, is I'm seeing very small different types of turbines and paddles begin used in things like irrigation feeds and stuff to take advantage of the water that's being forced down through them on our farms and like that. And even we're seeing on some of the rice farms, which are south of us here in Austin, that the water movement required for rice, they are actually beginning to put small embedded turbines in them too to generate power, more for charging batteries and for doing other things around it, and not connected up to the grid really. But that's another place where hydropower is being used pretty effectively right now. And just let me tack on to one thing that you were talking about. Uh, Most of the large, big outputs for hydroelectric power come from behind dams. And there's been multiple studies recently that we have passed the point where you're going to see many more of the big dams created. And uh, and particularly because of conservationists and others, that we are past that. So if I go back and just look at some statistics from the United Nations, that globally dams in the mid and late 1970s, there were about 1,500 dams a year going into construction, where in 2020 there was only about 50 at times, and that number has decreased since 2020. And most experts do not believe there will be another dam building sprint that will go back and do that and meet those areas. Um, and if I go back and look at the IRAN, which is the International Renewable Energy Agency, uh, they really says that the power generated, the capacity peaked in 2013 and then has dropped every year since then. So even though it's a great clean source, we're seeing the overall usage for the large dams, which are connected to the grid, really fall back. And even in China, which China was the world's most prolific dam builder, uh, they have cut back tremendously on their use of hydroelectric power from building new dams, and that we're seeing it. And Rob's correct. There are impacts for hydroelectric power in the dams, particularly up on the ecosystems around the dam, the fish, the vegetation, others like that. Uh, Also, dams displace people when the lakes are flooded and others like that. So if it's a dam that way, there's a lot of different types, and even earthquakes. Some of the earthquakes in India were attributed to some of the dams which were constructed and how they are put in place. So you see that, and Rob, thank you so much for really bring that up, because it is a major issue uh, of how it is, but is still one of the lowest cost ways to go and use that power. But really, we need to remember that these hydroelectric energy sources come in all sizes. And that they can work in many different places. Some of them can actually be damless, which are not necessarily a standard one. Multiple cities are using these damless facilities where they're just diverting part of a stream through a powerhouse before it goes back into the lake. So it's catching things like water runoff and others and using them to supplement the power which is generated there, which I think is a brilliant approach, as long as you're using it and storing it, which is what they tend to be doing with these small ones like that. I can tell you, we're having storms throughout Texas over end of last week, this week, with some even flooding. Just watching the power of some of the runoff, you would love to take advantage of that and use it. And the installation cost of it can be considerable for building a dam, but the turbines and things are really pretty straightforward in cost. And like I said, the use of this goes back thousands of years in different ways to generate energy as opposed to electricity. And we're still seeing that. We had recently a Renaissance festival over multiple weekends, and they generated a large part of their power by temporarily putting paddle wheels into the lake that ran through the river that ran through the facility, and generating enough power, mostly DC, to power a lot of the events at the festival. So you can see it being used there, and it is non-polluting, which is, like I said, one of the big advantages you have in that. So Sharif, that's a little bit more clarification.
Yeah, thank you, Professor Rob.
Well, we've kind of covered the gamut on this now. So is there a particular area you would like me to expand on? The energy source is clean. The portability that I've covered kind of the. Where do you want to take this, Sharif? Was there a particular question you wanted to?
Yeah, basically, this week we are working on water purifications and water energy utilizations in emerging economies, especially in South Asia. So, how hydropower can help this energy-related problem, specifically for Bangladesh?
Well, I don't know what your water sources are in Bangladesh.
We have 105 rivers. We have 105 rivers, including Ganga, like Himalayas.
Are they
From Himalayas?
Are they dammable?
Yes. Yes.
So they're at altitude. So you could dam and generate power from damming them. And what's the weather doing to your
We have
to
105.
your rain?
We have 105 rivers, especially from Himalayas. It's calm and it's go to Bay of Bengal.
So 105 rivers, but what's climate change doing to your rain?
Yes, climate change create a major problem right now. Right now we have heat wave, and many river also dying for that.
So that would indicate that hydroelectric power probably isn't a great solution for you, at least traditional hydroelectric power, right? You could certainly, because remember, hydroelectric power solution, it takes years to go in. Particularly a large dam could take over a decade to build, depending on the resources and size. And it's very likely that if you're already experiencing a reduction in rain and drought, that by the time you completed the dam, you wouldn't have enough water to run the generators. And so the issue then would be, how else would you use it? It would then, its best use would be much like I mentioned earlier. You'd use tidal generators near the coast. I'm sorry to say, I'm not even sure you have a coast, but you'd use tidal generators off the coast, or you'd use it as an energy storage mechanism. You'd pump water into an elevated area while you're generating with wind or solar, and then you would use hydroelectric power to generate energy when wind and solar were not viable because the wind was too low or the sun had gone down for the night. That would probably be the best use, and nothing says you couldn't use a river for that. But then you probably want to. In fact, if everything is drying up, assuming you're going to have a major farmland impact and an inability to irrigate, you might couple the solution with desalination, and then use the desalinated water to refill the reservoirs and rivers that you are then using to generate power and kill two birds with one stone. A growing clean water problem, which will dramatically affect agriculture, as done in South and Central America already, and then your energy generation solution comes out of that. So an approach that deals with both issues, both the inability to get enough water to irrigate farmland and the need to generate power when wind and solar are not viable. That would be probably the way I'd approach this. Coupled with this would be containment. You lose a lot of water due to evaporation, and so using various containment methods to reduce evaporation, both in transport for the water, changing some of the rivers. That's what we're doing here now. Is we're actually replacing a number of our smaller streams and rivers with pipes, and so the water goes in pipes. They determined that we lose more water due to evaporation than we use for farming, and right now farms are not getting enough water to grow crops. And so one of the big projects we've got right now is to encapsulate the streams and rivers. We haven't started to cover, as some areas, some geographies haven't started to cover the reservoirs with material to reduce evaporation, though I expect that's coming. We've just started to contain the rivers and streams in pipes to reduce evaporation during transport. And so that probably should be coupled in as well. So desalinization to increase the flow increase the resource of water, and then use that water as a energy storage mechanism to cover for when solar and wind are not viable might be the best way to approach a problem where your rain and water sources are at risk.
Professor Rob, can you give me some sort of example from North America, like you are utilizing hydropower? What area
We
you
are,
are
but
utilizing?
we're not necessarily using it as a storage mechanism. The deep mine, I don't remember where that was, but there are deep mine projects that are using it for energy storage. The mountain solution that people have gotten enthralled with of late is less water and more using a weighted train, but we'll see if that scales. We do pump large amounts of water in California, from Northern California to Southern California, but as is the case, that most of California has been undergoing a drought up till this year when they've had way too much water. Undergoing a drought. The Northern California suppliers have been wanting to cut off that pipeline for some time. So California's in dire straits, and a lot of the energy comes from a variety of dams that exist both in and outside of California and Oregon. And those dams are in many cases are in distress because of the lack of water. It's been a topic, almost a constant topic, that the dam outside of the huge dam outside of Las Vegas is almost not viable, and it's lower than I think it has ever been in recorded history, and the Hoover Dam, and that's proven to be a fairly significant problem because Las Vegas alone uses a massive amount of energy. And losing that energy source has become a significant issue. We are talking about putting in desalinization plants in California to address the water shortage, but it's mostly for water used by people, not by farms. To address the issue with farms, they've been forcing farmers to move from wasteful sources like flood irrigation to moving to drip or targeted sprinkler systems to reduce the amount of waste the farms have with water. But at this point, I don't think we're at any place in the United States we're doing desalinization at a scale that could replace water that comes in from rain. At least I'm not aware of anything at that scale. Most of the desalinization efforts I'm aware of are for personal use, not for the massive amount of water used by farming. And so farming has been focused on conservation, not recovery. And you see the huge conflicts between farms and those that are trying to preserve river wildlife like salmon, because the farms want the water, but if you use too much water, obviously, even if you don't have dams, the rivers get too shallow for the salmon to navigate. And again, you lose the spawning ground, and you could wipe out entire colonies of salmon that way. The farmers, I used to be a farmer myself, don't see that as big a problem as not being able to water the crops, but it's those kinds of conflicts that you have to overcome to make sure that you aren't wiping out large species of fish, and you're still able to assure your national food sources.
Thank you, Professor David Smith.
And Rob, let me just tack right on where you left it. The other challenge when you dam up some of these large rivers and things is the impact on communities and nations downstream from that. There have been ongoing conflicts, for example, between Pakistan, Afghanistan, India, over damming up the rivers there, which are coming off there, and how they impact the others, which have led to small armed conflicts and things, and is a flashpoint that could escalate into a much larger area there. So while water's there, water is a scarce resource today. And if you are damming it up and not releasing it where it can be used by others downstream, then it's going to create issues and others around that. But what is really nice about hydropower is, well, to build the dam, if you're using that technology, takes a while. But then you have a source that, like as Rod said earlier, and I said as well, lasts a long time. If you begin to think, you have storage hydroelectric power, which is the dams we've talked about. Rob talked about, and I referenced pump storage hydroelectric power, where it's pumped and used, like his comment with mines and other lakes and things where you use the change in elevation to do it. You have somewhere you're just using the power of the river and not damming it up. It's called a run-of-river hydropower. And then the two, which I think are real interesting also, is not just the tidal power, but also the wave power as two of the others, which can be really put there. But also understand that the hydropower, while there, it can generate a lot of power, but you still have to solve the transmission problems. For example, in Nevada, we have the Hoover Dam, which is not far from Las Vegas, and it generates about 4.5 billion kilowatts hours of electricity every year. But that is only enough to serve about 430,000 homes per year. And so you have to supplement it with others and do it. And you begin to see the others. The run-of-river hydropower, which is the one, Sharif, which I think would be used in Bangladesh in that area. The challenge with it is you're dependent totally upon the velocity of the river. It has no storage capability there, so the power will ebb and flow as the velocity and the levels of the river change. So you have that. So there's many different places, but to me, hydroelectric power is a very important part of the mix of power we have to do as we look at sustainability. And use there. It's very, I can, Bangladesh, for example, some of the tidal power being used there. I know over in Thailand, that's used a fair amount, particularly as you see how the currents ebb and flow around that to use in the ocean. So you have power sources like that as well. But the advantages of hydropower is, while there are some fairly high upfront costs, depending on the options you take and implement, it has been shown to be one of the most inexpensive forms of renewable energy over time. Once the necessary infrastructure is constructed, there's less maintenance required than almost any other form of energy. And we're seeing new science being applied to make it more efficient and effective too. And hydropower is produced domestically. And I think that's important for particularly developing nations, Sharif, in that there's not a lot of expensive things to secure from around the world. Control systems, maybe, but as you begin to look at it, it really is a fairly strong domestic product. And like I said earlier, the byproducts of hydropower, the water and things, are able to have other uses such as irrigation and power other places as well. And again, you cannot overemphasize that hydropower is clean and renewable, where fossil fuel is not, as you look at it. And it's efficient in that there's not much waste as you go through it. The other place where we're seeing it used, both around the United States and I think around Rob and I know around me here in Texas, is we're seeing that hydropower pairs well with other renewables, and it lets us handle a constant level, and it's capable of supporting energy from power sources that are not as consistent, like more intermediate, like wind and solar. Wind and solar rely on the natural ability of wind and sunlight, and at times they can be low wind, or at night the sun's not. However, hydroelectric power provides electricity when solar and wind are tanked, and wind cannot, making it more economical as you look there. But the other drawback is that they're non-dispatchable energy sources. That means they can't be used to generate electricity all the time, and that's where hydroelectric really comes in. But it's difficult trying to design a hydroelectric plant to meet peak demand because particularly since the movements, you have to use it in a hybrid view with many others. You know, disadvantages we've talked about, they can adversely affect the surrounding environment, particularly the natural flow of river, animal paths, fishing, and others. It could even affect some water quality and others. But you see that to build the large dams and the large reservoirs is a fairly expensive upfront process, but then it can provide low cost electricity for 50, 100 years after being built. So the overall cost is lower in the long run. And, you know, sometimes it takes a while to build up the resources for the hydroelectric reservoirs. Um, One of the reservoirs that we pull power on here in Austin varies during time of drought to times of flood by over 100 feet. We know in Nevada with what we're seeing on Lake Mead, how it almost dried up and it's now being replenished to be able to produce power through the dams which they have there. And so those are some of the other concerns. Dr. Sharif, some of the activities that would really be beneficial here, I think, particularly in the developing nation, is to begin to go back and look at the other basics here. You know, what can be done in the of power that can be generated here. You know, we've talked about waves, we've talked about tidal, we've talked about other types, some of, for example, the pump storage hydropower. Is there a way, particularly in developing nations, because of in many of them, access to more rural land and things without legacy systems impacting them? What new science could be brought to bear there? What new engineering can be brought to bear? And how can we look at ways to take better use of the hydropower? I love the ideas I've seen, particularly around me in farming and others, with small native turbines being used where water flow is happening, like in irrigation ditches, where you're pulling water off of a river to water crops and things, and they're running through these trenches at fairly high volume. Take advantage of that to generate power that can be used locally. We've talked a lot about mini and microgrids. You can use different types of hydropower to create small mini and microgrids to take advantage of it when it's producing power. And in many of the mini microgrids, you can build small enough storage arrays, batteries, and other things to capture the excess energy you have there to use at other times as well. So those are some of the places where I think the innovation, the entrepreneurship, and the science happening in developing nations can really take and use this away. Where in the United States, we have so much legacy. It's harder and harder to be innovative around hydropower in the United States.
Professor Rob.
Yeah. Well, really nothing much I can add. Do you have another question you'd like me to address?
We more discussing on the applications of hydropower.
Right.
So
We did.
water is the major sources of this energy. So
Right.
recently we are observing, at least in emerging economies, sources of water is going down. Many river is dying,
Right.
and many things happening for climate change. What do you think? How we can overcome from these climate change related challenges? Because water definitely very important for us.
I'd suggest going to Mars, but there's not a lot of water there either. Certainly not at altitude. But I think I mentioned that in the last go round. You moved, if it's for farming, you move aggressively towards conservation. Eliminate wasteful uses of water like flood irrigation, which is massively wasteful. You can go to targeted uses of either drip or intelligent sprinklers. You can move to vertical farming. where you contain the farming aspect into buildings and structures, and then you can not only better control water, but it's a very good way to eliminate or largely eliminate pesticides, because the insects can't get into the contained area as aggressively as they can in an open area. But if you're losing water, your first step is to reduce consumption through conservation, to reduce the loss, and then if it's still not enough, then you look at ways to create more water, like desalination, that would introduce water into the introduce water into the ecosystem. But you're because water is relatively cheap still, even when it's short, and it has historically been available in large quantities. We've been slow to apply conservation methods to it, and doing things like turning streams into pipelines and covering reservoirs would do a great deal to helping conservation, as would eliminating some of the most wasteful uses of water for farming. I don't know what your ratio is there, but here the vast majority of our water is used for farming. Farming consumes far more water than people do, and if you can address that farming overuse, you can at least delay the impact of water shortages on the population. But overall, moving to a much more aggressive form of water conservation would seem to be the best approach to a near-term water shortage problem. Oh, also assuring the water sources are not being contaminated. I know in Africa, there was a major program to train tribes in how to put in wells so they weren't contaminated by human waste, and because for a long time people were putting in wells next to septic tanks or waste pits, and the waste would make it into the groundwater and contaminate the wells, and then people were drinking water that had a lot of bacteria in it, and resulting in major spikes in illnesses, which isn't fun either. So making sure that whatever you're doing with the water doesn't pollute it, and aggressively going after companies and individuals that are putting in programs that are using policies that pollute the water, both fresh and salt, would be wise as well. Now you say, well, salt water, we've got plenty of oceans. Yeah, but it wipes out the fish, and fish is a food source. Plus, you may later want to desalinate that ocean water, and if it's got a bunch of heavy metals in it or chemicals, it's going to make the cost of removing those far more expensive. So water conservation, reducing pollution, reducing or eliminating as much as possible evaporation, and then increasingly funding efforts that are much more water efficient than traditional methods of irrigation would be wise, as well as monitoring human water use, assuring that you don't have a tremendous amount of waste. I remember in one of the companies I worked with, they had a huge fountain in the middle of the complex, and when that fountain was torn down, nobody realized that there was no pump. It was just an open spigot that was pumping water right down the drain, because water was just so cheap. They figured, well, what the hell? We'll just waste large amounts of water for the heck of it. And I imagine in every geography there are situations like that water was once so prevalent that just wasting, just pump, just for beauty, just pumping it out to the ocean was okay. It's not anymore. And so finding areas where water usage is excessive and eliminating the excessive nature of that water usage would be a very high priority for any nation that's experiencing water shortage at the moment.
Thank you. Professor David Smith.
I mean, Rob is 100% correct in what doing there. As we look at these shortages, as we look at them, one of the places where I'm seeing a lot of growth, though, is that, for example, the International Hydropower Association has put a lot more emphasis lately on what we talked about earlier, that is the pump storage technology, which involves releasing water from an upstream, a higher elevation through turbines when electricity demand and prices are high. They collect it downstream in another reservoir, and then They pump it back to the higher reservoir when electricity demand is low and and prices are low. So this becomes a cycle process with the point storage technology, where the water is reused over and over and over, as opposed to putting it down a stream and letting it flow to the ocean and other things like that. One of the advantages of this is that it has a smaller impact on the economy and on the ecosystem than some of the others. But it's one that is becoming more popular, particularly to supplement other types of energy uh, information, because it is a closed loop system in there. But the downside of it is pump storage systems typically consume more energy than they produce, but they're very useful in balancing electricity roads and systems that rely mostly on solar and wind power. And so you see that. Uh, the one part of the world has really been bucking the trends that we've seen of declining hydropower, and that is in Africa. And we're seeing some of it grow there, but we're going to see that very shortly. They've taken advantage of all the low-hanging fruit, so to speak, that's there, and you have to understand that those impacts are there. Also, we're seeing more and more application, not just of hydropower from the movements and the tidal movements. We're seeing more and more wind turbines taking advantage of offshore wind. So we're seeing places where they are combining the tidal and wave energy generation with offshore wind farms to be able to produce more uh, electricity, because the wind offshore tends to be a little bit more consistent than onshore. Not always the case. Like when I go fishing, I like the wind to be not that high, but it is a place to go and pull that type of energy. Uh, the last thing I kind of want to say here is you begin to look at uh, what is there, and you need to understand that there's good and bad of almost every type of sources that are used to generate energy. Hydro power, hydroelectricity is one of them. We've talked before about nuclear reactors. We've talked about the impact of fossil fuel. We've talked about the impact of solar and wind and others like that. So probably part of the real solution down the way is you need to take a where you use for your retail sense, and to have a mix of technologies and to look at different ways to distribute them. Again, one of the challenges with the large hydroelectric storage is that the dams tend to be a fairly good distance from where the end use of the energy is. And there's a lot of transmission loss for any type of energy being transmitted over wires between where it's generated and where it's used. That's one of the things that Nikola Tesla was trying to solve with his idea of wireless energy transmission. And as Rob and I both talked in another show, multiple companies around the world are trying to look at that technology and see if using today's technology can be refined and made more effective. But hydroelectric, where you have the environment to use it, it's a great source of power. Where the environment is consistent enough to have adequate water levels, adequate water flow, strong enough tidal currents and others, great source of energy. But it's a changing time with all the climate change that's going on right now, Sharif. So it's not a black and white answer, but one that you have to model because it is a local source of power generation. So it's something that you have to look at your region upstream and downstream from you to see the impacts. But it's a very interesting one to use as a mix in the energy production for any country that has the resources to support it.
Thank you. Professor Rob, what's your concluding remarks for today's session?
Well, for many emerging economies, because of climate change, traditional hydropower, hydroelectric power is probably not a viable source of energy. You have to go to a more advanced form of either using, as I mentioned, it for energy as a combination of an energy storage and release mechanism. It's simply because the lack of rain isn't repopulating the rivers and lakes and reservoirs at an adequate rate to assure that water power is going to be available going forward, unless you aggressively move to repopulate those rivers, lakes, and reservoirs using something like desalination. The hydroelectric power, what David pointed out, energy transport is one of the bigger problems with hydroelectric power, because you have to locate the power near the water source, but the use of the power can be quite removed. And in our case, for some of the hydroelectric power here in the United States, it could be large distances, and you lose a lot of energy through transport. Wireless power has a higher loss rate than wired power. And if we can figure out a way to safely solve that problem, like David has mentioned, it could be a real game changer. As can exploring alternative materials for generators that are coming into contact with water, whether that be tidal generators or more traditional hydroelectric generators. The metals and water just don't interact well, and if you come up with a material that better survives interaction with water, or coatings that last longer, you reduce the cost and the failure rates of the generators, which is also important. It remains a viable source of energy. But if we can solve wireless transport, orbital solar is probably a better long-term solution. Because then you get solar that is high yield. It is 24-hour generating, and potentially 24-hour generating, depending on where the satellites are located and how they're angled, and how far out you can put them. But that would be the end all be all if you could solve that transport problem. Right now you can do high yield energy transport, but it has relatively large health issues with it. Whether you're using microwave or laser, if something disrupts that beam, whatever that something is probably going to burst into flames or be destroyed. And not to mention, wouldn't do you any good if you walked underneath it, say if the satellite drifted. So solving that problem is not trivial. It is one of the tools in a toolbox, but because of climate change, it isn't anywhere near as powerful as it once was as a traditional source of energy. And we need to look at alternative ways to use the technology, metallurgy, and transport in order to assure that its use will go on into the future.
Thank you. Professor David Smith, what's your concluding remarks for today's session?
100% agree with what Rob said with some of the activities going forward and some of the opportunities there. Hydropower is often the forgotten giant of clean electricity, and it needs to be put into the mix on the energy and climate change agenda if countries are really serious about meeting their net zero goals. And we can see that going forward. Hydroelectric power is the backbone of low carbon electricity generating. And globally, like I said, it provides almost half of it today. And hydroelectric generation is higher than nuclear, larger than that of all the other renewables combined, which includes wind, solar, bioenergy, and geothermal. And you begin to look at it overall, hydro power supplied about 20% of the global electricity generation. It's the third largest source after coal and natural gas. And so you see that. And emerging developing economies actually have led the hydroelectric power growth since really the 1980s through public sector investment and investments by the large NGO financials like World Bank and International Development Bank, USAID, and others, and putting in hydroelectric plants to help meet the demands in developing economies. And it's a very cost-effective way to expand the access. On the other hand, you're seeing many of the older plants reaching the point where there needs to be expenditures to upgrade them and to repair them, so there's a lot of modernization that needs to be done in this area to be viable. The other thing is that strong sustainability standards are vital to unlock hydroelectric power generation's capability. It does have the lowest greenhouse gas emissions, but there needs to be more done to unlock it. But governments have a very important role in helping hydroelectric power have an impact well. For example, today, environmental assessment can be long, complex, and costly to get there. Looking at where to place them, looking at the cost of land and others. And there needs to be better visibility on revenue to attract investment at scale to do these. We know, even though there is talk about reducing the demand of electricity, we also know that with the movement to electric vehicles and others like that, the growth of computing and others, it's going to continue to be a growth time for electricity. And how are we going to meet that? How are we going to be able to use that to be sustainable in what we are doing, and be able to really put the pieces in place to do it? China, as I said before, is the largest hydroelectric power producer. And it's followed by the United States, Brazil, Canada, India, and Russia. And those are the top 6 in producing power from hydroelectrics. And we're going to see that going, because this is one of the energy producing areas with the largest lifespan. And so even though there's challenges, as Rob and I both talked about, there's still opportunities to use this, particularly in developing nations, as a key part of the energy to help elevate the economic development and the GDP, and the being able to put more dependable power to more people.
Thank you, Mr. David Smith, and thank you, Mr. Rob, for joining today's sessions. I request all of our audience, please share our content with your government agency, corporation, and academy. Thank you, everyone. Thank you. Bye-bye, and take care.
Bye, y'all.